the angle of elevation to the top of a tower is found to be 45 plus or minus 0.5 degrees from a point 450 plus or minus 0.2, well, I think is meters from the base of the tower. Estimate the height of the tower. Alright, we need a little diagram first. So if we have the tower and we have the point here, so we have angle of elevation 45 plus or minus 0.2 degrees right here. We have the distance, 45 plus or minus 0.5 degrees, not 2. 45 plus or minus 0.5. But the distance is 450 plus or minus 0.2. So from here to here, estimate the height of the tower. Height of the tower. Now, remember, you have the average measurements. If you can calculate, well, you're going to need that. But the fact that you have a plus or minus margin of error means that you're going to have the height and the margin of error for the height. Alright? So, let's see what's happening here now. We need a general equation for this thing. We need a general equation. So, if we do this, call this theta. Say this is x and this is h. Then tan theta is opposite h over adjacent x. So h is equal to x tan theta. Alright? I want you to pause the video, write this question down, and finish it off for me. Okay, you're done. Let's continue looking at the question. Now, if you're looking at average height or average values, what would happen? Remember, 450 plus or minus 0.2, the average would be 450. Some of these measurements, it might be 0.2 more or 0.2 less. So the average is 50. So here, the height, the average height, let me write AVG beside it. The average height is x, which is 450, times the tangent of 45. Now, what is the tan of 45? This is in degree. 45 tan is 1. So the average height would be 450 meters. Alright? Now, what happened is that you have a change in height. I represent using this curly delta. The change in height is the partial derivative of height with respect to x times the change in x plus partial derivative of height with respect to theta times change in theta. So you've seen this thing here before. This is a common equation you will see in partial derivative. Alright? You'd have seen it in Euler's theorem, where you have x times partial f by partial x plus y by partial f, or the function by partial y is equal to n times the function, right? You would have also seen it in other places, in other cases, like the tangent plane. Z minus z naught, that's a change in z, equal partial z, by partial x, change in x. But the change in x would have been x minus x naught plus partial z by partial y, change in y, which will be y minus y naught, right? So you see it quite often when you do partial differentiation, but we have it here. Now, what is the partial of h by partial x? It's going to be, well, if you differentiate, remember this is a function we're working with. If you differentiate this, you get tan theta. Alright? What is the partial of h with respect to theta? Well, you have to remember that when you differentiate tan x, you get x squared x. So when you differentiate the tan of theta, you get sec squared theta. So this is x times sec squared theta. Alright? So remember your table of derivatives, some of them, just like how you have to remember your timetable. You differentiate the first one, you get the second one. So you go sine, cos minus sine, tan x sec square x, right? Tan sec square, right? You have to remember those things. All right. Now, the thing is, you see the change in theta, in angle, it must be in radians. So we work in radians. We're going to work in radians for the angles. So here now. The change in the height is equal to partial height by partial x, which is tan theta times change in x plus partial h by partial theta, which is x sec squared theta times change in theta. Now theta is 45 degrees. I want it in radians. You just do all the angles in radians. 45 degrees is how many radians? You have to remember how to change degree to radians. If you have a full circle, that's 360 degrees. Now remember, 1 radian is the angle that is formed when the radius of the circle and the length of the arc between them, the 2 radii of the circle, the radius of the arc, and the length of the arc is the same as the radius, right? But that part of the arc is part of the circumference, and the full circumference is 2 pi times radius. So 360 degrees equal 2 pi radians. If you divide both sides by 2, you get 180 degrees is equal to pi radians. Remember that? So 180 degrees pi radians. So what is 45? Turn 180 into 1 and then turn the 1 into 45. To turn 180 into 1, you divide by 180. So 1 degree is pi over 180 radian. To turn 1 into 45, you multiply by 45. 45 by 1 is 45 degrees equal, you have pi over 180 times 45. You have radians, right? So it's 45 pi over 180. Well, you can cancel down later on. But that is the angle 45. Now, when you go to tan 45, you're going to need that. What is delta x? Well, the change in x is 0.2. Small change in x, delta x. So delta x, oh my, alright, the delta like 8. Delta x is equal to 0.2. Alright, what is delta theta, the change in theta? Now the change in theta, in degrees, it was, what was it again? 0.5, we want it in radians. 0.5 degrees, but we want it in radians, so remember, 1 degree is pi over 180 radians. So 0.5 degrees is 0.5 times pi over 180 radians. Alright? So it is 0.5 pi over 180 radians. Now we're ready to work. Now changing h, that change in h is equal to tan of 45 pi over 180 radians, tan of 45 pi over 180 radians. I put radian. Well, once you see pi, you know it's radians, it's not degrees, so you don't really see degrees and you see pi being used, right? So it's tan of 45 pi over 180 times the change in x. So, change in x is what? 0.2, right? Times 0.2 plus, what happened here now? X times, no, x is 450, right? Oh no, 450 times sec square of theta. So it's sec squared 45 pi over 180. Sec squared 45 pi over 180 times what now? Change in theta. The change in theta is 0.5 pi over 180. 0.5 pi over 180. Okay, good. So you have those values here now. Simplify some things now. Changing h is equal to tan of, now we have, right, let's put in radians from now. 45 times pi over 180 equal 0.785. Tan of 0.785. And by the way, let me put this in bracket because if you're not careful, you go and multiply this by the 0.2. Is when you find tan 0.785, after that you multiply by 0.2, right? Plus, now it's 450 times. Now you have to remember that 1 over sine is cosec, and 1 over cos is sec. So this will be 1 over cos 45 pi over 180. But it's cos square. It's squared. Remember, when you say cos theta and you square everything, it does not mean cos of theta square. No, it doesn't mean a square theta and behind find the cos of that. It means cos theta or squared. So you find cos theta first and then square everything. You have to remember those things, right? Alright, times, I'm going to write this. I'll let it remain 0.5 pi over 180. Alright, so the change in height is equal to, let's see how we work this thing out now. We have the 0.785 here. It's radians, right? Tan. You get 1. It's like 45 degrees, you know. Remember, this is 45 degrees. If you had the calculator in degrees and you say tan 45, you get 1. It's the same thing here. And 1 times 0.2 gives you 0.2, right? Plus 450 times 1 over. Alright, so we want to see how this one will go. We have 45 times pi over 180 equals, alright, we have that, and we cos 0.707. Now, we need to square that. So we don't really have a square directly here, but oh, see it here. Here it is, man. X squared. We get 0.5. So it's 1 over 0.5 times. Alright, I'll just keep this for now as 0.5 pi over 180. Now, changing h equals 0.2 plus. Alright. 0.5 cancels 0.5. See that? 0 cancels 0. So you have 45 pi over 18. So, we can work this out now and see what it is. So we have 45 times pi over 18 equals, and then we add that to 0.2 plus 0.2 equal 8.054. 8.054. Aha. So there we go. That's what we have there. So that's the small change in h. So therefore, the height equal, the estimated height equal, the average height would have been 450. So it is 450 plus or minus 8.054 meters.